Following is all the questions from exercise 14.3. Now, what we're going to be doing first is differentiating some easy ones like this, okay? Now, tan, however, isn't easy. Now, the only information you're going to be given is in your tables is this, okay? If y equals sine x, okay, what you're going to be told next is that dy dx, when you differentiate sine x, you get cos x, okay? The next thing you're going to be told is when y equals cos x, when you differentiate, you get minus sine x. Okay? You are given in your table that when you differentiate tan x, you get something called secant squared x. Okay? So let me look this up. You get dy dx equals secant squared x. Now, the truth is, you haven't done secant squared x yet, nor do I intend to use it. I'm not going to use it now either. I'm going to show you a way around it. It's basically 1 over cos squared x. Okay? Secant squared x is the same thing as 1 over cos squared x, but I'm going to show you a way around each one. Now, the problem is with this is that, don't mind the last one, okay? The problem is that basically you're not told anything about the number that comes in front of it. The number that comes in front of it affects it, and I'm going to show you how. Y equals sine 4x. By this logic, if you differentiate sine x, you should get cos x. By this logic, most people will put down the answer, this should equal cos 4x. That's half the answer. There's one little part you always got to do. You always have to differentiate the angle. So differentiate the angle and what happens? 4. Yeah? So the answer is 4 cos 4x. I'll give you another one that's not in the book at the moment, okay? Y equals sine a half x. Can anybody tell me what the answer to this one will be? Dy dx equals cos a half x. Differentiate the angle, we get a half. A half cos a half x.
So why don't you have to minus 1?
You just don't. Just different way of doing these ones, okay? Now, the next type of question we're going to have is number 2. Okay? Number 2 is y equals cos 3x. Now, once again, guys, like last time, what do you think the y dx is going to be this time? If you follow the rule literally, you'd get minus sine 3x. But what did we forget to do? Differentiate the angle and we get 3. Minus 3 sine 3x. Is that right? Alright, guys. Now, just want to have a quick look at the other questions. See if there's anything more difficult. Okay, there's nothing too much more difficult there, right? We'll try another one. Y equals cos 3x. Oh, sorry, we'll change that. 4x minus 5. What do you think about this one? The angle doesn't change, right? So it's going to be minus sine 4x minus 5. Differentiate the angle, what do we get? Just 4. So it's going to be minus 4 sine bracket 4x minus 4. Okay, that brings us to probably the most difficult one thus far, being tan. Now, in my solutions, I would have had it done with the old course. This has to be done the new way, the way that you'd be familiar with. Yes, Connor? Y equals tan x is the same thing as differentiating. In your tables, it will tell you that tan x is sine x over cos x. What I can do now is recognize that this is a quotient. And I can say dy dx equals phi times du dx minus u times dv dx all over phi squared. Now, what happens next is this, guys. U equals sine x. Du dx equals what? Cos x, yeah? The angle is 1, so you don't need to worry about it. Phi equals...
Bless you.
Thank you. Phi equals cos x. What's dv dx, guys? Minus sin x. Now, you're going to be doing a lot of this, okay? What you're going to be doing is this. You're then going to be doing dy dx, and you're going to need a bit of space for this. Dy dx ends up to be phi, which is cos x, times du dx, which is cos x, minus u, which is sin x, times dv dx, which is minus sin x, all divided by phi squared. And phi squared is cos squared x. Now look at this. Cos x by cos x, cos squared x. Sin x by minus sin x. Now what's cos squared x plus sin squared x?
1.
1. It's 1 over cos squared x. Everybody happy with that? Now, if we change the question to this, okay? If I change the question, and I'm just going to reuse basically everything I already have here. If I rechange the question to the question on part, because you guys don't use secant squared anymore, so that's why I had to show you a way around it. Now, tan 2x, what do you think tan 2x could be changed to? Sin 2x over cos 2x. If I said tan bx, that could be sin bx over cos bx. It doesn't matter what the angle is. It could be tan a million. Tan a million is sin a million divided by cos a million. Okay. Now, u is sin 2x. We got to differentiate. Now, what happens when you differentiate sin? It turns into cos. Now, it's a 2x this time, so we have to differentiate the angle, and what do we get? 2 cos 2x. Now, phi is cos 2x, and when you differentiate that, minus sin 2x. But we differentiate the angle again, Connor, and what do we get? 2. Okay, now we're going to have to put it all back into the dy dx formula. Dy dx ends up to be phi times du dx, which is cos 2x times 2 cos 2x minus sin 2x times minus sin 2x. Okay, I'm sorry, running out of space there, so I'm going to bring it all the way down here. Shh. Excuse me, guys. Okay. That's all going to be divided by cos 2x squared. Now, have a look at this, okay? Cos squared x multiplied by cos 2x. Anybody? 2 cos squared 2x. Those who don't understand that, it's y multiplied by 2y, which is 2y squared. Same thing. This one here, plus 2 sin squared 2x all over cos squared 2x, isn't it? Now look at this, guys. Here's the tricky part. If you were to say factorize out 2, and what you can get is 2 bracket cos squared 2x plus sin squared 2x all over cos squared x. What do you think about this here, guys? What's this here? It's 1. Cos squared any angle plus sin squared the same angle always equals 1. So the answer therefore is 2 over cos squared x. Oh, sorry, cos squared 2x. Sorry. Shh. Yeah, you're right, cos squared 2x. Connor, do you have a question?
Yes.
Now, once again, you might be asking, how do I know what to do, okay? The 2 things you need to have learned off by heart are this. Not even learned off by heart because it's in your notes. When you have a sin x, it differentiates into a cos x. When you have a cos x, it differentiates into minus sin x. Okay? That's all I have learnt off at this point in time. Now, look at question 9. Y equals x squared cos 2x. I realise there's two elements to this question. It tells me it's a differentiation question. U equals x squared, phi equals cos 2x. U equals x squared, du dx equals 2x. Phi equals cos 2x. Now, cos turns into minus sine, so here's how I understand what's going on. Cos turns into minus sine. Angle is always maintained. Differentiate the angle 2. It's a product rule. Write down the product rule and obey the product rule very rigidly, okay? So you're going to just obey whatever the product rule says. dy dx ends up to be u times dv dx plus phi times du dx. Okay? So what we're going to get is dy dx ends up to be u x squared dv dx, which is minus 2 sine 2x, plus phi, which is cos 2x, times du dx, which is 2x. Now we'll just multiply this out. I'm going to get minus 2x squared sine 2x plus 2x cos 2x. Now, this is question 9, right? I don't think there's anything I can do with that, to my knowledge. And there isn't. That's your answer. Just look at the back of the book, you'll see. Now, some people might say, well, look, you could factorise out 2x if you want. And you could say minus x sine 2x plus cos 2x. Be my guess, but it doesn't say any specific form. That's a product rule done, Andrew. It's a product rule done. Now you have to learn how to do the quotients. Now, the next thing we're going to do is a quotient drill. Okay? Quotient drill. Quotient drill. I'm going to show you now. Quotient drill is done here. Okay? Here's a standard quotient drill. Okay? And in this standard quotient drill, which is question 12, what we're going to do is we're going to find out which one is which. U is 1 plus sine x. Therefore, du dx is 1 turns to 0. Sine x turns into cos x. So it's simply cos x. Phi, which is the bottom, is cos x. Phi is cos x. This means what about dv dx? Minus sine x. Next part, quotient drill it. dy dx ends up to be phi times du dx minus u times dv dx all over phi squared. Okay? So what we're going to get is this. dy dx ends up to be phi times du dx, which is cos x, times du dx, which is cos x, minus u, which is 1 plus sine x, multiplied by minus sine x. Now look at this, guys. All over phi squared. Phi squared is going to be cos x squared. Now, minus times minus gets you a plus. Do you understand? Next we're going to get cos x by cos x, which is cos squared x. Sin x times 1, sin x. Sin x times sin x, sin squared x. Okay? Now, yeah. Okay. Now, lads, the worst thing about this one is, it's for you guys at home. Here's what you're going to have to do. What's cos squared x plus sin squared x? 1. Sorry, yeah. It's going to be, it's going to be sin x over cos squared x. Now, most of you would stop there. And I understand why you'd stop there. This is how you learn. You look to the back of the book and you'll go 1 minus sine x is the answer. Okay? Oh, sorry. That's 1 plus sine x on top. Excuse me. Cos squared x plus sine squared x is 1. 1 plus sine. You look at this and then you look at the answer in the back of the book and you'll be going, okay, this makes no sense. My answer doesn't look like that answer. So what you need to do first and foremost is get rid of the cos squared x. So cos squared x plus sine squared x equals 1. Sine squared x, cos squared x therefore is 1 minus sine squared x. Replace the cos squared x with 1 minus sine squared x. Now, anybody remember the difference of two squares? What's 1 minus y squared? Could anybody tell me? 1 minus y squared? 1 plus y, 1 minus y. Basically y is sine x. So you're going to get 1 plus sine x, 1 minus sine x, all over 1 plus sine x. Oh, sorry, what's that on the bottom again? Sorry, it's 1 over 1 minus sine x is the answer. So, okay, what cancels? And the answer is 1 over 1 minus sine x.
How many more did you not get for doing the last bit there?
Oh, you don't know, depends on the mark. Okay, that then brings us on to the chain rule. Finally, last part. Now, I'm going to do this one first, number 18. Would be a fair one to start off with. Okay? So, with number 18, we're doing the chain rule, and I'll explain why it's a chain rule. And I might do 16 after that, then I'll set you on your way. Okay? What we have here is... Okay, Frank. This rule here, what does square root mean as a power? Power of half. Y therefore equals cos 2x to the power of a half. Are you happy with that? Now, if you remembered from the last exercise, what you did was this. If I gave you, I'm trying to think of one now. Okay, if I gave you one like this, y equals 3x plus 2 to the power of a half. Here's what you did in the last exercise. In the last exercise, you brought the half to the front. You kept this the same. You took 1 away from the power it became, and then you differentiated what was in the bracket, which became 3. That's how you did the last exercise. This exercise is no different. Okay. Bring the half to the front. Connor. Bring the half to the front. What happens? A half cos 2x to the power of minus a half. But you also have to differentiate what's in the brackets. So how do you differentiate cos 2x? Alright, so cos 2x is going to change into minus sine 2x. Differentiate this, you get 2. Minus 2 sine 2x. Okay? And this is number 18, correct? Now, what's going to happen is this. We're going to have the 2's will cancel. And what we're going to have is minus sine 2x on top, cos 2x to the power of minus a half. What can you do with a minus power? You can bring it below and change the power of sine, and that will bring it to cos 2x to the power of a half. And cos 2x to the power of a half, what does that mean? It basically means the square root of cos 2x. Okay, one more and we're done, and I won't go any further today. Alright, the last one is we're going to do number 16, which is a more basic chain rule. Okay, just mark off the ones I did today. 16, I did 1, did 2, did 3, I did 9. Okay guys, last one, Frank. 16 equals y equals 1 plus sine squared x cubed. Now guys, what do you think for this one? Bring the 3 to the front, what happens? Do y dx equals 3, 1 plus sine squared x to the power of? Differentiate this. Here's the problem. If u equals 1 plus sine squared x, what's du dx? Now, here's the problem. Okay? In effect, what is sine squared x? Sine squared x is, I'll just do it down here. Sine squared x is 1 plus sine x squared. Now look at this. It's a chain rule. Okay? So when I differentiate this, what I'm going to get is 0. You bring the 2 to the front, don't you? Because it's a chain rule within itself. 2 sine x to the power of 1.
Then why does 1 become 0?
When you differentiate a number, it always becomes 0. Any number. 1,000,000 minus 1,000,000. That was in the first exercise. Okay? Now guys, when you differentiate sine x, what do you get? That's what happens when you differentiate sine x. You get cos x. So it's going to be sine x cos x, which is 2 sine x cos x. So the answer is going to be dy dx, continuing on from here, it's going to be 3 bracket 1 plus sine squared x squared, and then it's going to be at the very end, it's going to be 2 sine x cos x. Now, 2 sine x cos x. Now this is number 16, correct? Now, okay, I got it there, yeah. Okay guys, multiply the 3 by the 2 sine x cos x, you're going to get 6 sine x cos x into 1 plus sine squared x to the power of 2. That you're done. Okay.